Let's look at the line integral of a vector field. In this particular case, we have the vector field f, which is x squared, comma y squared, comma z squared, and we have the curve c with parameter domain 0 to pi represented by the vector function 7 sine t, comma 7 cosine t, comma 1/2 t squared. And I've written here in blue line integral of a vector field. Just like with the line integral of a scalar function, we still compute the velocity. And here we see from RT, we can get R prime by differentiating 7 cosine t, negative 7 sine t, and then of course t. Now, what we need to do when we think about the definition of the line integral of a vector field, we are utilizing the unit tangent. And because of the unit tangent, the actual speed factor in the integrand absorbs. And so you don't see that here. And that's the main difference. So when you actually move from the notation with the curve C to the parameter domain, that's the same. That is, we have 0 to pi, and we do the composition here with the actual vector function. So x squared becomes 49 sine squared, y squared becomes 49 cosine squared, and z squared, which squares this term, gives us 1/4 t to the 4th. And then of course we dot this with the differential dr. So we just move this term, 7 cosine t, negative sine t, and t dt here. Now of course we take the dot product. So again we have a 49 times 7 sine squared cosine t here. And then we have a 49 times 7 cosine squared. And then the sine t is where I put the negative, just because you can see how this will work with the integration method. And then for the last term, we have 1/4 t to the 4th times t, which gives us 1/4 t to the 5th. Now again, these are all power rule, because of course here we have the derivative of cosine is negative sine, and the derivative of sine is cosine, so everything's ready to go. So add 1, divide by the new power. For the first term here, we get 343, that is 7 times 49, times the cube of sine t divided by 3. In the second term, we get 343 times the cube of cosine divided by 3. And in the last term, we divide by 6, that gives us a 1/24, and then of course the new power being 6, so 1/24 t to the 6, all evaluated 0 to pi. Now of course, when we think of sine pi and sine 0, those are both 0 terms, so we get no contribution here other than 0. Now here, cosine pi and cosine 0 are non-zero terms, so we do want to consider them. And so the cosine of pi is -1, so cubing -1 gives us a -1. And of course the cosine of 0 is 1, and that will give us a -1 with the fundamental theorem. And then of course for the last term here, we just evaluated pi and 0, 0 giving us 0, but pi giving us pi to the 6 divided by 24. So now of course we just have 343 divided by 3 times the -2, which gives us -686 divided by 3, and then of course the positive term, pi to the 6 divided by 24. So again, the main difference here is that when we have a vector field, we have an integrand that is basically a dot product. So the computation is much simpler than that of a scalar function. And we are done.